Hello and welcome to today's webinar hosted by Packaging Europe in partnership with Vioneo. I'm Tim Sykes and I'll be moderating today's session. So those of you who are acquainted with Packaging Europe will be familiar with our mission to support the packaging value chain's understanding of the future demands it needs to meet in order to retain its license to operate. And central to these demands is the need to address the environmental footprint of packaging. And that's the focus of initiatives that we have, such as the Sustainable Packaging Summit, which takes place this year in Utrecht, the Netherlands, between the 10th and 12th of November. And today's topic, fossil-free plastics, is a really important part of the packaging sustainability agenda. But it's also a topic that I think is rather neglected in the wider circular economy discourse. So today we're going to be taking a deep dive into the transformative opportunity that it represents for European plastics to pursue a future of fossil-free plastics. And this is something that I think can be seen not just as an incremental change, but a strategic opportunity to align economic growth with ambitious climate and circularity goals. In the course of today's webinar, we'll be hearing about a groundbreaking new report from Systemic, launched just last week on the 28th of May, which outlines this pathway. And we'll also be introduced to Vioneo, a company pioneering large-scale production of these renewable materials. And then we'll go on to explore some of the strategic contexts around this. We'll also have a Q&A session to put you in charge of the agenda of this webinar. And let me, before we go any further, share a little bit more practical detail about how this webinar will proceed. So at about 10 minutes before the end of the webinar, we will have this Q&A audience session, and we really welcome your engagement in the webinar. So please do share any questions that you have through the chat on this interface, and we'll put as many as we have time for to the speakers. I see we've already received a number of questions from you, so if we don't have time to answer all of them, our speakers will be happy to follow up on individual questions afterwards. And then secondly, if you have any technical issues, please click on the support button, which you should be able to see on the left-hand side of your screen. So without further ado, let's meet our speakers. A warm welcome to Katia Wojciech, who is CCO of Vioneo, Ben Dixon, partner and head of materials and circular economy at Systemic, Hasso von Poggerel, Managing Director of European Bioplastics, Rob Obsamer, who is Executive Lead for Plastics and Finance at the Ellen MacArthur Foundation, and not on screen at the moment, but popping up when we get to the Q&A at the end, we'll also be joined by Michael Poulsen, who is Technical Lead at Vioneo. Welcome to all of our speakers, and let's kick off then. Ben Dixon, I'd like to start with you and maybe invite you to explain how Systemic views the role of fossil-free plastics, and maybe give us a snapshot of the report that you've just released.
Great, thank you very much, Tim, and thanks to all of those people who joined the webinar. Very excited to be here, excited to share this work. So let's get straight to it. So first of all, anybody who hasn't heard of Systemic before, we're a global sustainability firm. We're focused on the most challenging systemic topics. That's why we're called Systemic. And we attack these kind of topics through a combination of analytical research, coalition building and support for helping companies to work together, and then also various action and financing platforms. And as you can see from the page here, we've been heavily involved in the challenge of building a circular and zero emissions plastic system, and you see some of the studies that our team has built out over the last few years. So the reason I'm here today is to talk about a new piece of work that the team has been working on over the last couple of months, a deep dive study focused on fossil-free plastics, and this has been supported by Vioneo. You'll hear more from Vioneo in a minute. And we've had a fantastic group of advisors supporting us throughout the project, from academia, practitioners, NGOs, And we've been able to build on the extensive system modeling that we've done up to now on the plastic system. So I think there's 3 questions that we ought to try and cover here before we open up to the wider discussion. The first one is for those of you who kind of never really heard this term before, like what really is fossil-free plastic? Secondly, do we need them? Do we need fossil-free plastics in our European plastic system if we want to achieve a circular and net zero aligned system? And then lastly, if we want them, what's it going to take to scale up this new industry? So I'll try to briefly cover those, and I'm sure they'll be key to the discussion that we're about to have. Let's start with the basics. I think we can all agree plastics are everywhere. Most of you sitting wherever you are listening to this webinar will be able to see various different types of plastics around you. They play a valued role in our economy and in our daily lives. Plastics are also mostly carbon. The plastics in your bottle, your crisp packets, your running shoes, your car are all made from oil, natural gas, or coal. And this is what we mean by a fossil-based plastic system based on non-renewable carbon, so coming from the fossil fuel feedstocks. And that fossil-based plastic system contributes about 4% of global greenhouse gas emissions, a number that's going up. And basically this system, this industry is taking a growing share of our global carbon budget. But it doesn't have to be this way, because we can make plastics from renewable carbon. And this is what we mean by fossil-free plastics. Plastics made from renewable carbon sources, which is, it says here, certified biogenic feedstocks. That means plants. So we can make plastics from plants, or we can make plastics from atmospheric carbon, either from smokestack emissions or from direct air capture. Those are proven scaled technologies that exist today. Methanol to olefins is one example of a fossil-free plastics, which we'll hear about more from the Vioneo team in a minute. And there are other ways to do this, but this is basically a way of making plastics without using oil, natural gas, or coal. And do we need them in our net zero aligned future European plastic system? I think the first question we have to answer here is, do we need, how does this fit alongside the great kind of momentum that we have towards a circular plastic system? And I think the system modeling that we've carried out really helps to answer that question. And so what we do in our system modeling is we build a flow model of all the plastics in Europe. We then can use this model to project ourselves forward to 2050, when we're aiming for a net zero economy by 2050. And what we've consistently shown through all of the system modeling we've done over the last years is that circular economy approaches based on reduction, reuse, and recycling are the proven solutions that can get us to very significant greenhouse gas emission reductions and waste reduction. And this is rightly the focus of policy and corporate action. So big focus on those more traditional circular economy approaches. And I think what this chart here shows us is that, based on our modeling of an ambitious circularity scenario by 2050, we believe we need about 69 million tons of what we call plastic utility. So this is the equivalent, how much demand would there be under our kind of business as usual in 2050? If we push on these circular economy levers that I described, we can reduce the demand by about 15 million tons, and then about 26 million tons of that can be met through recycling. So this can, as I said, these circular economy approaches really drive a very significant impact, but it still leaves us with a demand for about 28 million tons of new plastic, virgin plastic, in 2050. So I think the first real takeaway here is that based on the modeling we've done, there's still a need for new plastic when we get to 2050, even if we push very, very hard on our circularity agenda. And we also know from many studies that have been done now that virgin plastic production and also the disposal of plastics through incineration is driving greenhouse gas emissions, which is, this chart shows us that if we add up the emissions from the production of plastics and end-of-life plastics when they reach an incinerator, the total cradle to grave emissions from a ton of plastics is close to 5 tons of CO2 equivalent. And that's on a fossil-based plastic system. I think the exciting point here is that once we start thinking about fossil-free plastics, we can really offer a very exciting alternative here, which is rather than a plastic system which is emitting 5 tons per ton, we can actually reach a system that has a net zero emissions, or even a carbon negative plastic system. And just to explain this rather complicated picture here, we have a kind of a 2x2 chart which shows us on the y-axis the source of carbon, where does the carbon come from in the plastic system, and on the x-axis the destination at the end of life, where does the carbon end up. And so our current plastic system that I've described is basically a ground to air system, which is the bottom left hand square here, where carbon from underground fossil fuel feedstocks is then emitted into the air at the end of life. But if we move to a fossil-free plastics production, we're basically taking carbon from the air with the potential to then sequester that carbon into durable plastics or into long-term carbon storage. And so if we follow that pathway, we can have a net reduction of 5 to 7 tons if we're comparing our fossil-free plastics to the fossil-based plastics. It's a very exciting idea that we can actually use our plastic system as a solution to climate change rather than a part of the problem. And then if we put all of this together, and I said, strong believers in driving those reduction, reuse, and recycling levers. And we call this an integrated scenario, where we say, if we drive as hard as possible on our circularity levers, and we also bring fossil-free plastics into the European plastic system, what does it add up to, at the system level? And what you can see here is a business as usual scenario for our European plastic system. At the bottom of the chart shows us 69 million tons of plastics production in 2050, mostly coming from fossil sources, because this is our business as usual scenario, giving us 180 million tons of greenhouse gas emissions. And in the integrated scenario, this idea of putting all of this together, we show through our modeling that it's possible to firstly reduce plastics demand, so from 69 down to 54 million tons in 2050, but very excitingly to see this pathway to get to a zero emissions plastic system by 2050. And as I said, this is a very exciting kind of climate story, but also we see there's a great socioeconomic opportunity here when we have a chemicals and plastics sector which is struggling with global competitiveness. And this idea that fossil-free plastics production can be a growth vector for that sector. Each production facility will bring in capital investments of north of €1 billion. The potential of a cumulative investment, therefore, of 30 to 40 billion by 2050, and driving new jobs, green jobs for Europe here. And we've estimated in our modelling 5,000 to 10,000 job creation in the fossil-free plastic sector by 2050. I think actually it could be much larger if we consider the overall value chain and the growth of a methanol economy. We've estimated up to 40,000 jobs in the study. So I think that gives a sense of the climate story, the socioeconomic story, and hopefully at least makes you very intrigued about, how could we bring this to life? Is this realistic? And maybe this is the last thing I'll talk about before handing back to Tim. What will it take to scale up fossil-free plastics production? And you'll see in our study that we've laid out a blueprint for bold and coordinated action between industry and the public sector. And just like many of these system changes, no one institution can achieve this on their own. And we're really calling for a coordinated approach and real ambition from policymakers and from industry. And I'll just speak to 2 of the steps here. I think the first step, which is so important, is to move on first projects. This will always be an interesting conversation until we have project development and real industrial development happening. In order to get first projects, of course, you need brave investors and brave project developers. And I think we're going to hear from Vioneo in a minute as an example of that. But you also need early adopter customers that are willing to join those investors and project developers in building this new industry. I think the second point here is about policy signals. And in this early stage, as this industry develops, critical importance of strong policy signals that will create confidence in those customers that policy will recognize the role of fossil-free plastics alongside the more traditional circular economy levers, which already have strong policy support in Europe. Lots more in this blueprint, so please do have a look at the report to find out more. And I think that sets us up for a good discussion. There's a lot more in our study, so please have a look at the report. And if you have questions, please put them in the chat. We'd really welcome follow-up. If you go to this web link, there's a clear way to send in your questions, and the team would be very happy to answer those. Thanks for listening, and I'm going to hand back to Tim.
Thank you very much, Ben. And let's now turn to Katja Wodorek. Katja, building on the picture that Ben has just outlined, could you introduce us to Vioneo and tell us how your strategic proposition addresses this landscape?
Thank you so much, Tim, and thank you, Ben, as well. I wish everyone who's on the line a very nice good morning, good afternoon, good evening from wherever you're dialing in. And I'm going to take, Ben, I'm going to take one of your last sentences. I wrote it down. What will it take to scale up? And you talked also about early adopter customers. We consider ourselves as a pioneer for fossil-free plastics. And I always like to say, when you're a pioneer and when you're one of the first ones, you need to partner up with pioneering customers and pioneering partners, and this is so nice illustrated in one of your last slides. So let's share an example on a project here on one of the companies, and I always like to start first. Why are we called Vioneo? Because the name already says a lot about it. Vioneo stands for new ways. And we like to call it new ways, the journey to net zero. What are new ways that are possible to make it happen? And we are a group of people that are really driven by making these plastics to turn it into an industry that is net zero. And we're also all aligned by being a believer that fossil-free solutions, fossil-free plastics is possible at scale. There's a lot of great projects out there. There's a lot of things that have been out and also developed over the last couple of years, and projects out now. But many times it's really this scalability to what is already out there. So let's unlock a little bit on what is a possibility out there. And what in essence we're going to work on, and we started to work on already over more than 2 years ago, before the company went live in October last year, is this opportunity to really turn green methanol into polyethylene and polypropylene that is then available as standard PE, a standard PP grade drop-in product, fully segregated, fully traceable, a drop-in solution. And that's really the interesting part, is going to deliver up to 6 kilo CO2 saving for every kilo of PE, PP out there. So with a huge CO2 saving, fossil-free, fully segregated, and so on. I always like to say, and that's a bit the reason why many of us joined the Vioneo, is we're working here on something where all stars are aligned. And when I say all stars are aligned, I look at it really a little bit as well, Ben, what you were talking as well. When you're working on a pioneering project, it takes many, it's not one. But we have here, I'm going to tell you a little bit about our owner. We have an investor and owner with a very long-term, purpose-driven mindset. We have a technology that is TRL readiness that is out there, that we're working on, also the technology partners we've engaged with and that are working with us. We have the right people. I always like to say I don't feel anymore to be the oldest in the room, because all of us, we bring a minimum of 20, 25, 30, 35 years of experience from all different big players out there. We have the right partners, and when I talk about partners, I really mean the suppliers, the off-takers, the people that we're working from all the sites out there to make this whole big project turn it into reality. And what I always consider the most important one, we have all the will to make this happen and to prove that it can be done at scale. So let me talk a bit about who's behind all of that, because that is, talking about all stars align, one of the big arguments on why we're so strongly behind feeling we have the muscle to make this happen. And if we can maybe turn on the next slide, if someone can bring this up. Thank you so much. I think from here I need to take it. Let me talk a little bit about our owner. We're backed by A.P. Møller Holding. They are sitting on many different companies. Among others, they are the owners of Maersk. And why do I mention this? Because scaling green methanol to olefin, setting an MTO plant, setting then later on a polymerization plant, everyone on the line or those that are in the industry know that this is a very heavy capex intensive project. And in fact, we're looking here at a project that has a capex needs of around 1.5 billion. So it's a long-term project. It takes a lot of capex. It's going to be a plan that we're planning out, and I'm showing this a bit in a second that you can really see what that means. Like, it's going to be state of the art. It's going to be sitting in Antwerp, so it will be an investment taking place in Europe. That I think in times like today, this is something very beautiful to look, a project in Europe. Very energy efficient, fantastic location, close to customers, in a very with all the facilities of the port of Antwerp and close to all the other players out there. And we're planning productions to start up end of 2028, 2029. So it's really a long-term project we're working on here, company. And after that, and that's really the important part, the idea is not to do just one plant. The idea, Tim and everyone on the line, the idea is to build a platform to start. We call it internally, we like to call it Vioneo 1. We know 300 KT. What we're looking at here is in the overall polymer market, not a huge asset. We know that there's a lot of bigger ones out there, but we purposely chose to go with that type of size for the first one out there. But we're planning to make this a global platform and really making an impact and being a solutionist for fossil-free plastics out there as virgin polymers. A.P. Møller Holding sits in the 5th generation. They are over 120 years. They always invest in companies, different type of companies, but all companies that need to deliver a positive impact to society along different themes, whether it's global trade, energy transition, circular water and waste, or also demographic and societal change. And you see here on this slide, you see the type of companies they have invested in. So there's a very strong understanding on how to scale up businesses in-house. And there's a strong understanding as well from the shipping industry on how the green methanol market works. So having, I always like to call it, strong brothers and sisters among us also makes us, as long as, I mean, we're standing as an independent company, but it's obviously in a good surrounding out there. So I talked already about the talents, and I always like to say that's one of the key ones. Sometimes when I go out, I hear things like, well, you guys they have never done this before. That's really often one of the things. And then I always like to say, well, anyone who's got now involved in Vioneo, the people that have been now since the company went live in October, we all bring a lot of experience in from very well-known different players. So it's a lot of fun that we're having as well to bring this mega project to life. Let's move into the next slide. And I think I need to do this myself here. And I purposely chose here my favorite slide, because I think a picture shows more than anything. The picture shows you what are we doing, but I also always like to say, what are we not doing? We're not going to produce green methanol. I always start with this because sometimes people get a bit confused. We are, in fact, instead of sourcing a standard polymer production today, you would have your cracker, you would be sourcing as your feedstock naphtha or gas. Well, we are going to use green methanol as a feedstock. So really a biogenic carbon, a bioatmospheric carbon that we're going to use. And then we're going to put, and that's really what you see in the light blue circle, we're going to put in Antwerp an MTO, a methanol to olefin plant out there. And we're going to put 2 polymerization plants, an LDPE plant and a polypropylene plant, all together and getting to a capacity of around 300 KT. We're planning all of that, and I can talk a little bit if the question comes up later on in terms of timing and project timeline. But we are aiming to get by the beginning of 2029 to get this whole thing running. And the outcome is going to be, like I said already before, standard drop in PE, PP. I got one of the first questions, and please encourage send more questions in that can be also mixed into any recycling efforts, because that is also an important part. But it is going to be fully segregated. It is going to be fossil free. It is going to give you significant CO2 savings. And like I said, it's going to be a lookalike PEPP. We have announced beginning of the year the technology provider and partner on the MTO. We're very happy to have Honeywell and UOP with us. They have a lot of experience into setting that kind of plans up, and we're very soon as well going to announce some very well established technology licensor on the polymer side of that. So there's a lot going on all the different work streams, whether it's on the sourcing side, whether it's on the off-taking side, and whether it's really the whole engineering part that is currently happening, and all my colleagues in Antwerp that are working on that. There's a lot going on to bring this project to life. That's more or less what I wanted to share as a teaser. I really encourage to bring a lot of more questions in. I don't know if we get to all of them. We've done an LCA study. We've done a lot of formats. We've been working on the project for more than 2-3 years. But maybe already what I like to say, because many times I get the questions around customers, how is that working, and how much is the interest, and we can talk about that later on as well. But there is really a need around an alignment as well on the regulatory side. That's one of the things I think, Hasso, you're going to talk a lot about that, or a little bit touch on that one as well. But there's a lot of high interest. There's a lot of willingness out there. But all the stars needs to be aligned as well from all the partners that are back to Ben's last slide. So I'm going to pause here, Tim, to give us more time also on the Q&A, and I think I'm going to hand over back to you.
Thank you very much, Katja. And so at this point, let's invite our other two speakers, Rob Opsema and Hasso van Poggerel, to join the screen. And I'd be interested to hear your reflections on what we've heard so far. Let's start with you, Hasso. How does this vision for fossil-free plastics resonate with your members and the broader industry goals that European bioplastics endorse?
Well, obviously it resonates very well because it is indeed in the core of our industry and the core of our association to promote all those players on the market who want to get away from using fossil fuels as a resource. So using, whether it's primary agricultural feedstock or whether it is more advanced different feedstocks, at the end of the day, we need to get away from fossil feedstock. And as was said in the first presentation, we need to be aware that plastics are not indefinitely recyclable. Every time they are recycled, they lose their strength. The carbon chains are shortened. So at the end of the day, you will always need virgin plastics in the circle. And our aim, of course, is to make sure that the virgin plastic that do have to enter the circle, that they are based on renewable feedstock. This is very important because that's the only way to get away from fossil feedstocks, which we know is not a good solution. What else can I say? I think the approach of Vioneo definitely has a very good future. The question, of course, is how well aligned is the legislation to really support this kind of development. I'm a bit skeptic on that in some cases because as usual, it comes in the nitty-gritty. So if you look at the package waste regulation, for example, the first draft that came out didn't have any mention of bio-based content in there. It only came in the second draft when we also pushed for it, that we said we need a bio-based content in plastic packaging. I mean, there's two ways. You could say you either have a minimum bio-based content in plastic packaging, or what may even be more suitable is, because the Commission is asking for recycled content targets, that it may make sense to replace, at least in parts, the recycled content with bio-based content targets. So if you have, for example, the need to fulfill 35% of your plastic needs to be recycled content, you should be able to do that in a combined content of recycled or bio-based content. That would make sense to push forward to using renewable resources, and I think this is something that we definitely need to push forward.
Yeah, thank you. Rob, what are your reflections on what we've heard so far, and maybe specifically on the findings of Systemic's reports and that broader vision for fossil-free plastics?
Yeah, thanks, Tim. And I think the findings really match very well with the way how we look at the topic. And I think something perhaps people don't always know. I think many people, when they hear circular economy, they think reuse recycling, because it actually visually goes in circles. But for us at the Ellen MacArthur Foundation, from the very start in 2010, one of the core principles of a circular economy has also been that it should be powered by renewables, renewable energy, but also renewable materials. And when it comes to plastics specifically, again, our view is that ultimately in the long term, we should decouple from fossil feedstocks in the first instance by reducing the amount of plastics we use, by making sure we reduce the amount of virgin plastics we use. But then the remaining virgin, which will always in the foreseeable future be there, should be sourced from responsibly sourced renewable feedstocks. And I think what's interesting about it, that's not just my view or the Ellen MacArthur's view, that's actually a view with which, through an effort that we've run with UNEP called the Global Commitment, have 1,000 organizations around the world who have endorsed that vision, and that is a core component of that. So I would say that would be my initial reflection, that for me that complementarity between, on the one hand, looking at how can we reduce the demand for virgin materials, but then for the remainder, how do we scale up actually powerful solutions to source that from renewable feedstocks, is very well aligned with the vision of a circular economy that we've been promoting for the last 15 years.
Thanks very much. Well, let's widen the discussion a little bit and allow all four speakers to bounce ideas off each other. So I'd like to welcome back Katja and Ben to the discussion. And first of all, I'd like to explore a tension or a suggested tension that's been already referenced in this previous remarks between the goals of circularity and bio-based. Maybe, Rob, we could start with you. And could I ask you, the Foundation's work so far has really emphasized the need for a circular economy that's powered by renewable inputs. How do you think we ensure that fossil-free plastics are complementary to demand reduction, reuse and recycling? And what are the critical conditions you think are there to ensure that there aren't unintended competition between the two approaches?
Yeah, thanks, Tim. And I would say, first of all, I don't see conceptually any conflict between circularity, circular economy, and bio-based renewable inputs, because again, in our view of circular economy, renewable inputs are a part of that. So it's part of the overall frame. I would say then, for me, largely what the study has shown really is that even in the most optimistic, realistic scenarios, even by 2050, even in Europe, we'll still need a lot of virgin inputs. And that's, for me, consistent with all the studies and all the work I've seen so far. When we look at the actual trends of what's playing out, consistent with that. And I would say, for me, the idea of a conflict between different solutions here is largely theoretical for me. I think it's the least of my worries that one of those solutions will scale so fast. And we can say the same thing of recycling versus investing in reuse, for example. Do we still need recycling facility if everything is reused forever? Do we still need bio-based if everything is vice versa? I think the least of my worries is that any of these solutions scale so fast that we don't need the others anymore. I think in any realistic scenarios for the next several decades, we need all of these solutions at the same time to go as fast as we can. And I think this study and this work by Vioneo is a really good addition to making sure that we can actually deploy as fast as we can.
Okay, thank you. And Ben, maybe exploring the same idea, do you think there's a risk of the focus on fossil-free plastics distracting or slowing the progress on circularity when you think of the stakeholders that are trying to meet, you know, certain regulatory demands on recycling, PCR, etc. Is there a kind of conflict, not on a theoretical level, but maybe in terms of practical outcomes?
I mean, there could be, Tim. So I think it's important to flag this, because, and I think coming back to something that Hasso had talked about there, you know, there is a risk here where you end up saying, gosh, this recycling thing is really hard, so let's kind of put that on the back burner and put everything onto fossil-free plastics now. I think that'd be a real mistake, right? And I think the way Rob described it was perfect. You know, we need to scale up all of these solutions as fast as we bloody well can if we're going to make a dent in this system challenge that we have in front of us. So I think we should be thinking not about this as like, you know, let's reduce our recycling target, put up our fossil-free target. I think we need to be thinking in an additive way. Let's keep the high ambition that we have on, you know, reuse, reduction, and recycling, and then let's also have a high ambition on fossil-free plastics. And I think that's the right way to think about, you know, how we should be trying to embed this into policy.
Mm-hmm. Okay, thank you. Well, I'd like to explore other strategic challenges, barriers, or levers that we can pull. And one of the maybe familiar questions that arises when we talk about any kind of bio-based plastics is whether there's some kind of competition between the use of biomass for fossil-free plastics, or even biofuels or other applications, and food production. Hasso, I know that's a question that you have to field quite often with European bioplastics. How do you see that?
Yes, indeed, we have to deal with that very often. It's one of the first questions that we get. How is that compatible to use possibly even food feedstock to make bioplastics? But if we look at the numbers of how much land use, because this is the area that you would have to look at, how much land use is really taken up for the production of bioplastics, it's infinitesimally small. I mean, if we look at the charts, we can see that most of the land use is for food and feed, and especially for, at the end of the day, creating meat that we all eat. I always like to say, as only half a joke, that if we would pass up on one or the other steak, we would need to have a discussion about using renewable feedstock or food grade feedstock to make bioplastics, because their impact is so small, even in a scenario where bio-based plastics would indeed take up a much higher percentage than it do today. So for me, there is no real competition of food and feed. It's a matter of distribution. The fact that we have hunger in some areas of the world is not because we don't have enough food or feed, but it's the distribution, the politics around it. That's the issue, not the amount of food or feed that would be used.
Okay, thank you. And Katja, could I turn to you on that same question? Is that something that Vioneo has to answer, and what is your response to that question of food competition?
We look at waste. So the green methanol we're looking is really the agricultural waste. And I saw the question just coming up, and it's an absolutely fair one. We look at the waste component of it. There's different ways of green methanol, how you get that out, but it's really agricultural waste. And we have very stringent supply chain, how we look in this, where it comes from. And I think it's a very fair comment as well. You don't want to create other competitions out there with the waste chain. So I can clearly make a reference here as agricultural waste.
Okay, thank you. Perfect. So another potential challenge or question that we have around this is the scalability. And I'd like to ask Ben whether you see any feasibility issues around achieving the kinds of scales that we need to have a genuine impact on shifting away from fossil-based plastics.
Thanks, Tim. I mean, I think this is really interesting, because what we're talking about here is not a moonshot technology. This is something where every step of the value chain is proven and operates at scale already. So this is actually something where, you know, we feel low technology risk in this topic. I think we've just spoken about some of the questions around biomass sourcing, and I think that's an important topic. But I think you know, previous research that Systemic has done has highlighted, you know, we've actually looked at all of the sustainable biomass sources globally, and really prioritized potential uses of that. And I think our view is that sustainable biomass access shouldn't be a challenge. Of course, we need to be very careful about where that's coming from, but overall, we feel that shouldn't be a critical factor in challenging the scale up of fossil-free plastics. But I think that the big challenge is really about the market, you know, customer demand for this, and what we described as these kind of pioneer or early adopter customers that are willing to partner up with the project developers to get this industry off the ground, because we shouldn't beat around the bush. This is more expensive than fossil-based plastics today. And unless there are customers who are willing to come on board and you know, be part of this journey, then it won't scale. So I think the biggest challenge for scale is on the market side.
Okay, thank you. So another challenge that we've already alluded to within the discussion so far is the regulatory context. And Ben, in his remarks earlier, called for coordinated action involving policy. Hasso, you've already flagged this. Are there any specific policy enablers, Hasso, that you think would be particularly impactful in helping to accelerate the uptake of fossil-free plastics?
Yes, of course. Maybe what I said before, and maybe that was misunderstood when we're talking about maybe combining recycled content targets and bio-based targets. Maybe I didn't formulate it quite correctly. I was not saying that they should substitute it. I have no issue with the fact that you would maybe add another component to the recycled content targets, but it should be a translucent way. So you should be able to reach those potentially even higher targets with a combination, which would be good. So that would be an enabler. I think an enabler would be, or something very necessary, as Rob said, we need to make sure that the renewable resources are sustainably sourced. We completely agree with that, so we are very happy with it. And you may know that the packaging waste regulation is going to create a sustainability criteria for the renewable resources for making bioplastics, for example. We are perfectly fine with that. It, of course, has to be adapted to the specific needs of the industry. I mean, for fossil fuels, comparing fossil fuels and bio-based fuels is a very simple thing. And there you can, but for bioplastics, for example, you have very many different kinds of polymers, very different kinds of applications. So trying to find something that is always comparable on the other side from the fossil-based industry can be difficult. So this has to be adapted. But in principle, we completely agree that we need to make sure that the resources are sustainably sourced. So we are definitely in line with that.
Thanks very much. And Rob, Ben just flagged the importance of the boldness and the commitments that people in the value chain need to show to enable the fossil-free plastics to grow. Within the Ellen MacArthur Foundation and your global commitment, you have a direct relationship with the brands involved in the value chain. How do you see their attitudes to this? And do you think that the discussion that we're having today fits comfortably with the existing commitments that brand owners have? Do you think we need to see a shift in mindset within the brand's sustainability teams?
Yeah, thanks, Tim. And I think we really need to look here at how does this contribute to which areas of overall sustainability goals that brands have. And for me, the most obvious and immediate way this contributes is to climate goals. Most of the big brands already have climate goals. worked with a lot of consumer goods brands. The share that packaging represents of total climate footprint will depend based on the portfolio, but it's often 10, 20, sometimes up to 30% of the carbon footprint. And so clearly this is an enormously important lever to address that part of the carbon footprint. And again, that is something that brands already have. So in that sense, I don't know if it's about a change in direction because the goals are there. Packaging is a big part of the footprint, but then making sure that this part gets recognized. When it comes to goals around packaging specifically, there I think we need to get back to the complementarity. Many brands, particularly if you look at a global level, when brands think about packaging, waste and pollution is often top of mind, and the impacts of that on economies around the world. Again, not just in Europe, but if you take a global perspective, you all know what the impacts are. This solution, I would say by design, because one of the great things about this solution, they are drop-in polymers, so they are identical, comes with many benefits. It also means that it doesn't directly address that waste and pollution issue. So there we do need to look at the complementarity, that we do still want brands to have strategies and targets that directly address their waste and pollution. But then again, this is a really important part of the solution for other goals around decoupling from fossil fuels and getting to net zero.
Thank you very much. And Katja, I'll give you the last word in this discussion part of the webinar. Could you give us an insight into the key milestones that you envisage for Vioneo coming up in the coming years? And what are your kind of key aspirations in terms of the partnerships that you're looking for?
The aspirations are big. So maybe I go first in history. We started working on Vioneo, the team, before me and some of our colleagues coming already more than 2 years. We went live October last year. We have a couple of 2-3 months ago, we started with the feed. So we're doing the whole design part. And at the same time as well, securing the offtake, the supplier side of us, and we're targeting, I saw there was one of the questions as well in the chat, we're targeting FID, so meaning the final investment decision is targeted for end of the year. And then practically after that, from a timeline perspective, that's when things get seriously. And that's when when the plan is to start building in Antwerp. And obviously we're talking here not a small investment, not a small plant. Just for clarification, was also one question. We will be planning to build one MTO, one polyethylene, one polypropylene plant, and that is then targeted to finalize by end of 28, around 29.
Perfect. Thank you very much. Right, so let's hand control over the rest of the webinar to our audience, and we'll move on to our Q&A session. We've had plenty of questions coming in, and please do continue to submit them through the chat. And as I mentioned earlier, we're very pleased to welcome one more speaker who is going to support us with the more technical questions that you might put to us. And I'm pleased to add now Michael Poulsen from Vioneo into the call. Now, before I share our first question for our panelists, I'd like to put a question first to you, the audience, and we're going to put a poll to you. So this will appear on your screen shortly. And I'd like to invite you to respond to it. So the question is, before joining this webinar, how familiar were you with fossil-free plastics and the methanol to olefins technology pathway? Now, while we give you a few moments to answer that, I'm going to ask Michael, welcome to the call. So am I right to understand, Michael, that MTO technology is already kind of well developed and in use in China?
Indeed. Good afternoon, everybody. Pleasure speaking with you. Indeed, Tim, the core methanol to olefins, or MTO technology, is industrially proven, with UOP having built 7 full-scale industrial plants since 2013, and all of them actually bigger than what we're building. In China, they are fed with coal-based methanol and coal-based utilities such as electricity and steam. In Vioneo, we use sustainable methanol, as you heard, And in addition, the whole plant will be electrified to the highest possible level using sustainable or renewable electricity. And furthermore, we are in the engineering, we are paying special attention to energy efficiency, heat integration, and absolute minimization of any emissions, not just CO2. And minimization of the environmental footprint is a major aspect of the ongoing engineering.
Okay.
But
Thanks
yes,
very much.
it is
Yeah.
certainly
It's mature technology. Yeah. Okay, great. And well, our audience is pretty well educated about it already. So we have the largest cohort, 55% is somewhat familiar, and then further nearly 16% is very familiar. So hopefully we're adding some additional knowledge and detail to that. So let's go immediately into our audience questions and try to answer as many as we have time for. First one, and I'm going to put this to, I think, first of all, Katja, and then to Ben. The Vioneo project brings a refreshing and positive story to a struggling EU industry. Economic reasons are pushing several crackers to shutdowns. How do you see Vioneo navigating in this cost-driven environment? Katja.
I would probably say let's maybe have a more generic view. Ben, maybe if you can take the first one and then I can complement, because we're coming in as something completely new to this and we're not building on the old that is there, and that's the pioneering part. So I think it may be the reverse. Ben, if you can take this first from a comparison and then I can chime in.
Happy to catch it. I mean, we've looked at this in the study. So again, another reason for everybody to have a look at the study, and got some real economics in there, just giving people, I think, a sense of what is the cost of olefins from this pathway expected to be today, but also like how does this play out over the next years? And I think that's a really important piece of the puzzle. So, I think we absolutely recognize that this is a more expensive product. I would argue that it's not a comparable product because of the environmental benefits that come with every ton of plastic. But I think it's treating it as a kind of drop in it. It is a more expensive product. But what you can see from the analysis that we've done is, as we move forward, the kind of differential between fossil-free and fossil-based plastics is expected to reduce significantly. And we've actually shown the kind of assumptions that we would take to show how this can reach parity with fossil-based plastics. So, and that's a mixture of the learning, as you scale up an industry, you have benefits that reduce your cost in terms of learning, but also in terms of scale effects. But also, as we see that the cost of carbon is increasingly priced into fossil-based plastic production through, investments in CCS or through, carbon taxes, etc. So we've provided those numbers, and it basically says, over the next years, we can see a pathway to get from something like 3,000 euros per ton for olefin production through this pathway down to something like 2,000 euros per ton, if we take into account all of these other factors, which gets you approximately to parity with fossil. So I think the key message is there is a pathway forwards to achieve that. But of course, we need to scale this industry in order to get it. It's not going to happen by magic. Katja, over to you to fill in the gaps.
And now it's a good moment to pick it up really on the on what does it mean for the customer from a pricing, because I think, Tim, it's a very fair question. We look at a very dark picture at the moment when we look at the industry from a cost perspective as well. Now, the project we're looking here, the methanol to olefin, making it live and scaling it, that's going to take 3-4 years. So if you were to compare today pricing and cost comparison, yes, there is a significant premium over fossil, but this also matches with the significant CO2 saving. And then you need to kind of look into, this is only going to really come live in 3-4 years. And in 3-4 years, the world is going to look very different, because we do know that there's going to be an increase on CO2 costs. We do expect as well that there will be processing, scaling ability, also both on the production side as well, but also from a feedstock perspective. And we expect, and then there's a certain type of parity taking place, and that's really what the report also confirmed. But I do like to again highlight, this is something, and that's the beauty of the question was it's a really refreshing and positive story. There is a very purposeful decision to do this all in Antwerp, to do this all in Europe. because there's a belief that there's a lot of good things there. And yes, there is a cost dynamics out there, but there is a lot that talks at the moment to do something at that scale and really bring this as a huge opportunity for Europe, in Europe, with European talents, and making that happening here.
Thank you very much. We have another question, which is how are the performance features of fossil-free plastic or resin versus virgin resin? Is it used for consumer food packaging applications? So there's that question about applications, and we have a separate question that's been asking about end-of-life pathways. So perhaps we can put those two questions together. Michael, I think your connectivity dropped and then you came back again, so I'll just repeat that. I'll put this question to you, Michael, about the performance of fossil-free plastic versus virgin in applications. Can it be used in the same applications as virgin resin? And also, is it recyclable in the same way as virgin plastics?
Indeed, chemically, the polymer is identical to what is known in the market based on fossil carbon. The one difference, which is very significant but doesn't impact the performance, is that it's biogenic carbon that's in there. More than 99% will be biogenic carbon, verifiable through a carbon-14 test or analysis. And this also means that at the end of life, the polymers can participate in the recycling structures that exist today fully and completely.
Okay, perfect. Thank you. Okay, another question. Bio-based looks much better than chemical recycling in terms of LCA. That's a question. That's a statement rather than a question. The question is, can you confirm? Who could take the carbon footprint question here? Go on, Hasse.
I can have a first go at that, Tim, and then
okay.
Anybody else feel free to jump in. And I think it gets a little bit to the points that we've made before. I think there's various different LCAs out there looking at the relative carbon emissions from pyrolysis-based chemical recycling, for example, which is the most relevant topic here, I think, given we're talking about this particular type of plastics. And I think some of the studies we've seen have shown that those pyrolysis-based chemical recycling technologies do have benefits compared to virgin fossil production. They also have benefits because they're using waste as a feedstock rather than using virgin. So I think if we look at in the round, we can see that there are benefits from those technologies. And I think it's not probably like I think at this point we shouldn't be necessarily saying is it A or B, because I think coming back to the previous points we've made, I think that the point here is we need to find ways to scale up all of the potential solutions, both for climate benefits but also for waste and pollution benefits. And so I think I think there's plenty of studies out there for people to dig into, and I think Vioneo also has a good set of LCA data now that I think is really starting to put the picture together. But I would encourage the audience to think not so much about either or, but actually really think about how do we scale up all of these solutions in parallel.
Okay, thank you. And very briefly, I'll ask one final question to Katja, which is whether the new plant in Antwerp will be a greenfield investment or is it leveraging existing assets?
It's a completely new asset that we're building there. Yeah.
Okay, perfect.
Yeah.
Thank you. Great. So we would like to end by launching one more poll for you, the audience, and I'm going to put it on screen now. So the question we'd like to ask is, how confident are you that combining circular economy strategies with fossil-free plastics can deliver a circular, net zero and competitive plastics system in Europe? Are you very confident, somewhat confident, not very confident, or not confident at all? And while we give you a moment to answer that question, I'd like to ask Rob maybe one final question. Is there a final takeaway that you would suggest to our audience from today's webinar, Rob?
Yeah, thanks, Tim, and thanks everyone for tuning in again. I would say my final takeaway would be, we've touched upon it a number of times, the complementarity. We should look at how do we reduce the demand for virgin materials, how do we tackle some of the waste and pollution issues related to plastics use, and we should decouple from fossil feedstocks, and we should scale fossil-free plastics and renewable materials. So it's really about all of them, not an either or.
Perfect, thank you. And I think that message is reinforced by our poll, in fact. So we've got about 3/4 have said that you're very confident or somewhat confident in this, and no one is saying that they're not confident at all, which is great. So we've come to the end of today's webinar, and I think we've encountered some really compelling new ideas. The systemic report sending a very strong message about the importance of fossil-free plastics. Vioneo has presented its readiness to deliver on this. We've also seen the importance and significance of support from industry associations and civil society organizations like European Bioplastics and the Ellen MacArthur Foundation in underscoring the timeliness and necessity of this transition. And I think a very strong takeaway for me is the importance of encouraging policymakers to engage with this topic and recognize the role that fossil-free can play in achieving our holistic environmental goals in Europe. So it remains just to say, if you would like to follow up on today's insights, you can access the full systemic report at systemic.earth/FFP, or you can scan the QR code that you see on screen right now. If you want to learn more about Vioneo, please visit their website, vioneo.com. And finally, we will be emailing you in the coming days with links so that you can access both a recording of this webinar and the slides that have been shared. Special thanks to Ben, Katja, Rob, Hasso, and Michael for sharing your expertise in the webinar. And thanks to you, our audience, for joining and engaging with those great questions. We'll be back again soon.